Hello viewers. So today we'll take an important topic in differential calculus, and the name of our topic is differentiation using logarithms. Viewers, before taking this topic, let me take some elementary definitions and elementary results related to logarithms. So let us take the first one. Let y equal to fx be the general exponential function where a is greater than 1. Clear? So what is the derivative of this function? Clear? So we can write this function as y equal to e logarithm of e raised to x. Why? Because we can here we have used that e raised to log fx, some function fx is equal to fx. So here fx is a raised to x. Okay, so we write it as e raised to x log of a to the base e. Clear? Here we have used the property of logarithm as log e. If it is m raised to n, then it is n log m. Clear? Now we differentiate it. So when we differentiate it, we get dy over dx is the derivative of exponential function is the exponential function itself. So here we have e raised to x log ea, and then by chain rule we differentiate this function and we get the derivative of x is 1, so we get log ea. Hence we write the derivative of we substitute y is equal to a raised to x is equal to e raised to x log ea is y, and y is a raised to x. So this is a raised to x multiplied log ea. So viewers, we have this result. Clear? Now here we will add two more results also, and the result is log of m raised to n is n log m. Here we are considering the base as e. Clear? Now we will have one more result here, log emn, that is the product rule for logarithms, and this is log em plus log of n to the base e. Similarly, we have log e of m by n is equal to log em minus log of en. Clear? Now this is one thing. Now let us come to the second thing, which is I think most important result in logarithms. So far we have discussed the derivative of this log of x, and it is 1 over x. Now this result is true when we have the base e. Clear? Now if we change this base, then what will be the derivative of log x? Let us say if I write log of say bx. Now what is the derivative of this function log of x to the base b? So friends, here we'll use the base changing formula, and the base changing formula says that here I will write it. The base changing formula says that say if we have BA then we can write it as EA and log of EB. Clear? So we have changed this base B to the base E. Clear? So here we apply this result. So we get d by dx of log bx. So we'll change this base B to the base E. Clear? So let us do it. So we have log ex over log E B. Clear? Now we see that this term is a constant, so we take it outside the derivative sign, so we get log of ex. Clear? And the derivative of log x to the base e is 1 over x, so we have 1 over log eb multiplied 1 over x, which can further be written as 1 over x ln b. Clear? So this is the formula for that is we can write it here as log bx is equal to 1 over x log of b. Clear? Now let us take an example. Suppose we have to find the derivative of log, say, 7x. So what is the derivative of this function, log x to the base 7? So we'll make use of this formula. So here the value of b is 7. So therefore we'll directly write the result as log e7. Clear? So dear friends, we have discussed these important results regarding logarithms, and so now we'll move further to our main discussion, that is differentiation using logarithms. Viewers, logarithms is a powerful technique used to simplify mathematical expressions. Clear? Now in this section we are going to differentiate some complicated functions using the properties of logarithms. So let us start with a simple example to illustrate the characteristic feature of logarithms. So let us take an example here. Suppose we have a function y equal to, say, sin x, sin x is sin 2x and sin 3x. Clear? Now here we have a product of three functions. So what we will do, we will make use of the log function or the properties of logarithms. So what we will do, we will first take, here we have to find the derivative of y with respect to x. So we will take log of both sides. So what we will get, log of y and log of sin x, sin 2x and sin 3x. Clear? Now here, say this is a, this is b and this is c. So in fact we have a, b, c. Now the property of the product rule, here we will apply this rule mn. So we will have log m plus log n. So similarly here we have log of a plus log of b plus log of c. Now we substitute the values here. So we have log of sin x plus log of sin 2x plus log of sin 3x. Clear? Now we differentiate both sides with respect to x. So when we differentiate log y, we will get since if it is log x, then we straight away write 1 over x, but it is log y. So first we'll differentiate y, log y with respect to y, so we'll get 1 over y. Then by applying the chain rule, we have dy over dx. Okay? So always remember, the derivative of log x with respect to x is 1 over x, but the derivative of log y with respect to x is 1 over y dy over dx. Clear? So here we'll apply the formula. So the derivative of log sin x, where we know that the derivative of log x is 1 over x. So therefore the derivative of log sin x is 1 over sin x multiplied, then we'll apply the chain rule, the derivative of sin x is cos x, plus the second term, this is 1 over sin 2x. Then we'll differentiate this sin 2x, we will have sin cos 2x, and then we'll differentiate 2x by making use of chain rule, so we'll get 2 plus, and similar is the explanation for this, 1 over sin 3x multiplied cos 3x multiplied 3. Clear? So we have 1 over y dy over dx equal to, this is cot x plus this is 2 cot 2x, and this is 3 cot 3x. Clear? Now we take this y to this side, so we get dy by dx is equal to y times cot x plus 2 cot 2x plus 3 cot 3x, and then we can here substitute this value of y, so we get sin x, sin 2x, sin 3x, and here we have cot x plus 2 cot 2x plus 3 cot 3x. So this is the required derivative. Clear? Let us take this problem. Here we have to differentiate this function, and we wish to find the derivative of y with respect to x. So viewers, here we will not directly differentiate this function, instead we'll make use of logarithms. So let us first do the squaring on both sides. So what we will get, y square x minus 1 x minus 2 x minus 3. Now we'll take log of both sides. So what we will get, this is log x minus 1, here x minus 2 and x minus 3. Clear? First we have done the squaring on both sides, then we will take the log of both sides. Clear? Now by this property, log m raised to n is equal to log of n log m, we'll have 2 log y. Clear? And here we'll apply the product rule for logarithms, that is log of x minus 1 plus log of x minus 2 plus log of x minus 3. Clear? Now we differentiate both sides, so we'll have 2 is constants, and the derivative of log y is 1 over y dy over dx. So this is 2 over y dy over dx. The derivative of log x minus 1 is 1 over x minus 1, and if we apply the chain rule, the derivative of x is 1 and 1 is 0, so we'll have only 1. Similarly, here we have x minus 2 and here we have x minus 3. Now we'll take this y to this side, and we have dy over dx is equal to y times over 2, and here we have 1 over x minus 1 plus 1 over x minus 2 over 1 over x minus 3. Clear? Now we'll substitute here the value of y. So y is square root of x minus 1, x minus 2 and x minus 3, and in bracket we have 1 over x minus 1 over x minus 2 over x minus 3. This is the required value of the derivative. If we can also further simplify this expression by taking LCM. Now I leave it to you as an exercise. Clear? Now let us take one more example. Here we have a function fx equal to x raised to sin x. Now let us take it as y. Now we'll take the logarithm of both sides. So we'll get log y, log of x raised to sin x. Clear? Now we have log y, and we take this sin x to this side. We'll have sin x log of x, because here we have used this property. Again I am mentioning it, log m raised to n is equal to n log m. Clear? So now differentiate both sides with respect to y. So here we'll have 1 over y dy over dx. Now here we have sin x log x. So this is the product of two functions. So we'll apply the product rule for differentiation. So this is first function. Derivative of log x is 1 over x. Then second function, derivative of sin x is cos x. Clear? Now we'll take this y to this side. So we have dy over dx equal to y times of sin x over x plus cos x and log x. Clear? Now in the next step we can substitute the value of y, because we have to express this derivative in terms of x only. So we'll substitute the value of y here, that is x raised to sin x, and here we have sin x over x plus cos x and log x. So this is the required derivative of y equal to x raised to sin x with respect to x. Now let us take one more example. Here we are given y raised to x multiplied x raised to y equal to 1. We have to find the derivative of y with respect to x. So here we have this expression. Now what we will do, we'll take the logarithm of both sides. Clear? We'll take the log of both sides. So here we have this log of y raised to x multiply x raised to y equal to log of 1. Now here we'll apply the product rule. So we'll get y raised to x, this rule. Clear? Y raised to x plus log x raised to y, and the value of log 1 is 0. Clear? Log 1 is 0. So here we have 0. Now we'll apply this rule. Log m raised to n is n log m. Clear? So here we'll apply it. So we'll have x log y plus y log x equal to 0. So now we have this expression. This looks quite comfortable as compared to this expression. So here we see that how logarithms are useful to us in simplifying the complex algebraic expressions. So now we'll differentiate both sides with respect to x, and here we see that this is a function, this is a product of two functions. Here also we have the product of two functions, and here we'll apply the product rule. Here also we'll apply the product rule. So let us apply the product rule in this function. So this is x, derivative of log y is 1 over y dy over dx plus log y, and the derivative of x is 1. So the term corresponding to this one. Now plus, now for this term we have first function y, derivative of log x is 1 over x, then we have log x multiplied derivative of y, clear, equal to 0. Now we'll collect the terms containing dy by dx. So here we have x over y, this is x over y, and here we have log x, clear, and dy over dx, plus here we have, this is log y, this is plus y over x, clear, this term and this term equal to 0. So here we can write x plus y log x over y, dy over dx, and here we can write x log y by taking LCM plus y over x equal to 0. Now we'll take this term to this side, so we'll have x plus y log x over y dy over dx equal to minus of x log y plus y over x, clear. So dy by dx can be written as, this y will go to this side, so y over x and x log y plus y, and this term will come to the denominator of this expression, so we have x plus y log x. So this is the required derivative of y with respect to x for this expression, clear. Viewers, now let us take one more very important question, and the question is y equal to x raised to x plus log x raised to x. Now we have to find here dy over dx. Now here we will have to be very careful because here we will not take the log on both sides directly, clear. Instead, if we have a function which is a combination of 2 or 3 functions in this form, then what we will do, we will assume this function as say first function u, and let us assume this function as v. So we'll write y as u plus v, clear. I think it is clear to you. We'll write u as x raised to x and v as log x raised to x, clear. Now what we will do, we have y equal to u plus v, so we have to find dy over dx. So therefore dy over dx is equal to du over dx plus dv over dx, because we'll individually differentiate these two functions with respect to x. Now it means we have to find dy by dx. Now here du by dx and dv by dx, so du by dx will be obtained by this function, and dv by dx will be obtained by this function. So let us find these two derivatives one by one. So first we'll take this u, x raised to x. Now take logarithm of both sides as usual, so we have log x raised to x. So log u is equal to, we'll take this x by this property, log m raised to n is n log m. So we have log u equal to x log x. Now differentiating both sides, we get 1 over u du over dx. Now here we have the product of two functions, so x multiplied, the derivative of log x is 1 over x, log x, derivative of x is 1. So we have finally du over dx will take u to this side, and this x get cancelled, 1 plus log x, clear. or we'll take this value of u. So this is x raised to x 1 plus log x. Clear? So this is our first derivative. Now we have for the second one we have v is equal to log x raised to x. Now we'll take the log of both sides. We get log v and log of log x of x. Again we'll make use of this property. So this x will come to this place. So we have log v is equal to x log of log x. Clear? Now we'll differentiate both sides. So we'll get 1 over v dv over dx equal to, now again this becomes the product of two functions, and the product of two functions we will apply this rule. Say u and v are two functions, so u dv by dx plus v du by dx. So here also we'll apply x. Log of log x is 1 over log x, then the derivative of log x is 1 over x plus log of x, and the derivative of x is 1. So dv by dx, we'll take v to this side, so we'll have v, x get cancelled, 1 over log x plus log of x. Now we'll substitute the value of v as log x raised to x. So this is log x raised to x 1 over log x plus log of log x. Clear? So we have this expression, and this is question number 2. Now we'll substitute the value of du over dx as this value and dv over dx as this value in equation this. Say this is equation number alpha. So in that case our dy over dx, this dy over dx becomes for du by dx we'll have x raised to x, and here we'll have 1 plus log x, and plus this becomes log x raised to x, and here we have 1 over log x plus log of log x. Clear? Now we can further simplify this expression as x raised to x. Now 1 can be written as log of e plus say log of this is x plus log of x raised to x, and here we have 1 plus, we'll take LCM here, log x multiplied log of x. Clear? And in denominator we have log of x. Then we'll write x raised to x, log e plus log x will become log of ex, plus this 1 power will be subtracted from this, so we'll have log of x minus 1. Clear? This expression will go to the numerator, and we have here we have 1 plus say log x multiplied log of x. So this is the required expression. Clear? So viewers, let us take one more example. Here we have y equal to square root of x plus y. Now we have to prove that dy over dx is equal to 1 over 2y minus 1. So here what we will do, first we will take the we'll do the squaring on both sides. So what we'll get, y square is equal to x plus y. Clear? Now we can take the take log of both sides, and then we'll have say this is log of y square and this is log of x plus y. Clear? So this expression becomes 2 log y and this is log of x plus y. Now we'll differentiate both sides with respect to x. So this becomes 2 multiplied 1 over y dy over dx, and here we'll have 1 over the derivative of log x is 1 over x, so it is log of x plus y is 1 over x plus y, and then we'll by chain rule we'll differentiate this. So the derivative of x is 1 plus this is dy over dx. Clear? Now we'll simplify it. This is 2 over y and we'll take 1 minus x plus y as we'll collect the terms here, and here we have 1 over x plus y. Clear? Now taking the LCM, we'll have 2 times of x plus 2y. We'll multiply cross multiplication y over x plus y, and here we have y. This is the derivative of y with respect to x, so this is x plus y. So here this and this get cancelled. Here we'll have 2x and 2y minus y is 2y minus y is y, so this is 2x plus y and over y, and dy over dx is equal to 1. Now what we will do, we'll take it as dy over dx is equal to y over 2x plus y. Clear? Now we'll substitute the value of x. Here we'll substitute the value of x from this equation. See, from this equation x is y square minus y. So here we have substituted this value. Okay, so this is y, 2y square minus 2y plus y. So we will have y over 2y square, and minus 2y plus y is minus y, and taking y as common we have 2y minus 1. So y get cancelled and we are left with 1 over 2y minus 1. So this is our required result. Clear?